Hello, my name is Yeru Choi. Today I will present how I created a real-time event-driven simulation built with Node.js and KafKa.js. Before I started, Professor, I want to mention that this is an individual submission. Now it's a few hours before a deadline, but so far we haven't had a good chance to discuss the project with my teammates meaningfully. Um, so yeah, I made an effort to gather the arrange the meeting, but it was difficult uh, to do that even today. So I had to prepare and submit it myself to ensure my grade wouldn't be affected. Because for the past times, a few times, uh, the same things happen over and over again. So we had to submitted late, so I think it would affect my grade bad. So I had no choice but to do it this way. But I provide my code to my teammates both, so they will work on my code and they definitely submit the LAB5 as well. So what I mean is I want to make sure that I want you to know that I'm still part of the team, but for this case, this time I'm going to submit individually. And yeah, so please understand my situation, and please know that I still contribute to the teamwork with the code provision, and um, but for this times I'm going to do it individually. Okay, get back to the presentation. Yeah, this simulation demonstrates how the warehouse inventory system communicates asynchronously with the CRM alert system using Kafka topic. Um, I thought about the two use cases because the focus of the project is warehouse inventory system. The first case I thought about is the automated replenishment. For example, when a product is purchased, the warehouse inventory system sends a stock update. On the other hand, the CRA alert system detects the low stock, then it can automatically trigger a purchase order to the suppliers. The second use case is customer notification. If a wish list item is running low, the system can send a real-time alert such as only two left, buy now before it's gone, things like that. So in this system, the warehouse inventory system notifies the inventory status and the CRM alert system responds. So in a nutshell, the warehouse inventory system acts as the producer. The CRM alert system acts as a consumer, and the communication between them is handled by the Kafka topic. The Kafka topic is also called as like a broker, right? Um, yeah, I will show you my Confluent because the now currently running the code, so it's still working. Here is the producer. This is the warehouse inventory system. In my case, this is a producer, and it continuously sends a message to the Kafka topic. The consumer, in my case, is a CRM alert system. This is subscribed to that topic to receive the updates. The Kafka topics act as a middle layer, ensuring the smooth communication between them. So I will show you the topic here. I tried to show you the message. Here is the message. So my app, every 5 seconds, the event is sent to the Kafka. Then the consumer is respond every 5 seconds. So let me take you to my code here. On the left hand side is a producer, and the right hand side is a consumer. And I opened the terminal. I created two terminals, and each of them is running right now. Um, Let me briefly explain the code here. The producers continuously the simulated stimulate the inventory changes and stream them to the Kafka for other system to consume. At first, to load the key information like Kafka server and the username and password. The detail is saved in the environment, the env file. And then it set up a Kafka producer with the SSL authentication to securely connect to the broker. Like, and on the this is not a dynamic code, not a real server. So this is the created for the purpose of demonstration. So I set the code to uh, send the event every 5 seconds. So now it keeps moving. On the right hand side, this is the consumer. The event sent by the consumer continuously listen for the inventory update from the Kafka broker and allows the CRM system to respond automatically to low stock situation. It starts by loading the information like here, same information, and creating the Kafka consumer assigned to the consumer group, which allows the multiple consumers to share the workload. The consumer subscribed to CRM event topic and only process the new messages sent after it starts. So in conclusion, this project demonstrates a real-time event-driven communication system between the warehouse inventory system and a CRM alert system using Kafka. The producers simulate the inventory update, Kafka handles the messages streamings, and the consumers automatically react to the low stock event. This is all for my presentation. Thank you.